Hi guys, good to see you again. Mr. Kane here.
Morning, guys. It's Mrs. G. Mr. Kane?
Yes, Mrs. G.
What is on your board right now? Why is there a hand on your board?
There's a hand. It's I needed a hand, so somebody gave me a hand. A student left a glove in class. I'm sure that they'll be watching this video and go, "That's my glove!"
It's not even winter. Why would they have a glove on already?
I don't know.
I don't understand.
It was right there between the second and third row yesterday.
Okay.
And yesterday was October... Yesterday was October
15th.
something. Yeah, 15th.
Yes.
Yeah, today's the 16th. It's quarter exam day.
Ooh.
And we're doing percent compositions.
And
So, Mrs. G,
yes, sir.
if there are 50 questions...
All right. Percent composition. Percentage by mass of an element in a compound, molecule, or formula unit.
Okay. So the calculation for percent comp looks kind of familiar here.
Anytime you see anything that has a percentage, it's usually that part over the entire whole times 100. We're just going to do mass.
That's just a piece. It's kind of like a grade. How many you got right out of how many there were total.
Total points, yep.
Yeah. So we're just doing this by math. If I wanted to find the percent composition of carbon in something sweet like glucose,
Okay. You'd need the mass of the carbon over the total mass of the compound, yeah?
I believe so, yeah.
Okay.
So first I need to know the mass of the compound.
Now, how'd you figure that one out?
Well, it's just the molar mass,
Okay.
which we figure out by taking 6 carbons, which are each 12.01 apiece, 12 hydrogens, which are 1.01 apiece, and 6 oxygens, which are 16.00 apiece, and we add up all of those masses of all
Okay.
of the atoms, and we get 180.18 grams.
Okay, so that's the mass of 1 mole. Got it.
Right. The mass of the carbon in this compound is 6 carbons.
All right.
So 6 times 12.01 gives us 72.06.
And it's the mass of the
And
carbon.
that should
okay.
be in grams.
All right.
Right. Okay. So in order to calculate the percent comp here, we're going to take the 72.06. We're going to divide it by 180.18. And of course there's units here, which interestingly enough cancel. We're going to multiply this by 100 to get a percentage. And I think we want 4 sig figs on this one.
Yep, so 39.99%.
All right, 39.99% sounds pretty decent.
Now, you could actually do that for the hydrogen and the oxygen too, right? It'd be the top number would be different.
Oh yeah, if I was doing it for the hydrogen, it'd be 12.01 over 180.18 times 100, and now there's grams and grams which cancel.
And it's 180.18. So that'd be about 6.67%.
6.67%. And I guess I should start labeling these since we're doing them all.
Yeah.
This is carbon. This is hydrogen. And let's see, oxygen is 6 times 16, which is
96.
96.00 divided by 180.18.
53.28%.
53.28% oxygen. And I'm going to circle the answers here.
So you can do either one that's been specified, or if it just says what's the mass percent, you just do them all.
You can do them all, yeah.
All right. Well, that's easy enough. Good
Easy
heavens. Yeah.
Okay. Now we should double check this here. 53.28 plus 39.99 plus 6.67. Hundredths place on all of them.
Ooh, that's only 99.94%.
99.94%. Is that okay that I didn't get exactly 100%?
Yep.
I got 3 problems where I rounded my final answer on each of the 3. So I'm probably expecting my accuracy not to be perfect.
Right.
Yeah.
Yep.
Since I rounded 3 times.
Good thing we did that precision section first. Explains a lot of that.
Yes, it does.
Now this one's different.
This one's a little bit different. Yeah, let's see. They tell us that we've got a compound, made of aluminum and bromine, and that it weighs 266.68 grams.
So that's the mass of the compound there.
So what we're going to have to do is we're going to have to think about it. The mass of the aluminum, well, no, we don't have to think about it. This is given to us.
So this is lab data.
This is lab data.
The other one was a formula. This is just lab data, isn't it?
They've actually decomposed the compound that had aluminum bromine in it. And they found out that 26.98 grams was aluminum.
Okay.
So if we're trying to figure out the percent comp of aluminum, we're going to take 26.98 grams and divide it by the total mass,
of the
266.68 grams. Multiply by 100, and we're going to get 10.116994415 in our calculator, which will round to have 4 sig figs, so 10.12.
Okay.
Now the bromine given to us, when they decompose it, they weighed out the bromine and they found out it's 239.70 grams.
It's a larger mass, so I would expect it to be a larger percentage.
Right, so we're going to expect a larger percentage, you know. So when we do the percent mass here, the calculator spits out about 89%, and we're going to write down 89.88 because of sig fig rules.
Okay.
Okay.
Well, that was easy. Even though it's a little different, it was easy.
Yep. 10.12 plus 89.88 gives us perfectly 100.00%. I got to have the hundredths place because we're adding.
Yeah.
Right? So 100%. This one turned out perfect.
Yeah.
Okay. Sometimes they turn out perfect, sometimes they don't.
Yeah. So there are two types of problems. Type number one, you're going to be given the formula and asked for the percentages of each element in the formula.
And type number two, you're going to be given some lab data, which you'll be given the total mass of the compound plus the masses of each component of the compound, each of the elements, and you'll be asked to do percentage that way.
But the mechanics are still the same. Part over whole times 100.
Part over whole times 100.
All right, that's easy enough.
Here we go, guys. We're done. Homework number 3. Take these 2 problems on a clean sheet of notebook paper with a title on top, show all work.
Yep, make sure your name's on it, and look at that. One problem is given the formula, and the other one is the lab data.
That's nice.
How hard this is going to be. It's going to take forever.
Yeah, especially since we didn't teach any of this. Oh, if you didn't understand, go back and rewatch.
Yep.